Hey, I'm MC Toon, and it's Tuesday night, and we've got Viki Falcon last week said I want to come on and show you my stuff, show you what I got, and so Viki, I messaged today. I wasn't sure what was going on, because there was a little bit of silence from Viki, but then I got a message back from Viki, and I sent the Discord link. And Viki started talking to me. And so I have now with me Viki that I was introduced to as a but there's a little more to the story. So welcome, person representing Viki.
Can you hear me? Okay.
I can,
just
yes.
want to make sure.
All right,
Okay.
well, why don't you go through
what
you
happened?
briefly told me there? Yes.
Okay, so let me go through what happened. So first things first, I do want to get one thing out of the way fast. Myself, I'm not the Viki Falcon. And it actually turns out that he's not very much of a falcon. He's, let's say he's another kind of bird, a chicken, because he chickened out earlier today. It turns out when he saw that he was actually going to be on a show, like, with McToon, like when the video premiere or whatever that thing is called was posted onto YouTube, he got flustered. And he's not even in the apartment right now where I am. He's my roommate. So, but luckily I had access to his Discord. So I was able to jump on in his stead. And I wanted to do so for a number of different reasons. So, the first one is so there's no dead air. That would be kind of annoying, especially for McToon. I feel bad for him. But also because I want to present some of his ideas and some of the things he's talking about on behalf of him too. So we can all sort of analyze that and maybe talk about it. So yeah.
So you have your version of his presentation that you created.
Yeah.
Right? Because being your roommate, he's talked to you about it, I'm sure, incessantly.
Oh, yeah.
So, okay. Let me get set up. You can...
Now, I do want to ask you something. I don't know how much time, my Flurfy McFlurf face guy asks you to set aside for him. I know it probably isn't much because one of his tactics is to say he's out of time, in air quotes, when he's asked any remotely hard question, and then he just dashes away. Like he doesn't even give any like good rationale for why he has to go or why he's out of time. He just says he's out of time and then he's out of there.
He gets uncomfortable.
So, I just wanted to know how much time you have.
I don't have an end time. My parents no longer care what time I go to bed.
Yeah, because I got a lot of stuff to talk about. So
okay, and so let me just put this out there, Viki. If you happen to be listening in and you're sitting in cowering somewhere as the non-Falcon you are, the invitation is here. I won't extend it to you again, most likely. But contact me. And I mean, if you're on Discord, you can see the link. It's sitting there in your account that your roommate has picked up for you to fill in your stead. And he's going to do, I'm sure, the best effort he can to present your claims in absentia. So here we go.
Yeah, I do have a what to call again, a PowerPoint presentation. So
you can share. Can I share that
screen?
Yep, down at the bottom there, you can share screen.
Alrighty, let me just. Okay, I don't know. Will my name appear here?
Your name is Viki Falcon to me, so that's but
no,
yeah.
I meant like when I'm opening up PowerPoint, it's like I'm logged into my Outlook account. I don't know if I should tell you what or not.
It's not on screen. Nobody will see right now. Me. So if you trust me to see your PowerPoint,
that's fine.
I'll make sure, and then I can crop it so that anything that exposes who you are is hidden.
Yeah. I'm sorry about that. All right, so let me share this with you, right? Just you?
Yes, just me. Yeah.
Okay. All right, is that good?
All
See
right.
that?
I see. All right, I do see, and yep, I can crop
Oh,
that
oops,
for you.
I went to your stream, I think. Oops, I'm sorry about that. Okay, there
No,
we go.
I don't. All right, there you go. Cropped off. The name
Wait,
is
can I?
Flurpy Presentation. Oh, your name is right there in the thing. You need
No,
to
that's
change
fine. That's
that.
fine. It's
Oh, your
fine.
first
It's
name.
fine.
Okay. Okay.
It's my first name. It's fine.
All right. Well, all right. Let me set this up so the scene is set, and then all right. Well, and you'll just go. You'll page through your because if you do present in it takes over your whole screen, and that's actually not very good for going over Zoom. So
Yeah.
all right.
Wait, if I press the escape button, will it?
Give it a
Oh, I
shot.
can't do that. Okay, never mind. I can't do that. I'm
Stringer
just.
News, Stringer News 1 is wondering, does this mean we are getting the Viki treatment? So, the Viki treatment is when a flat earther comes into chat and starts talking crap. And this was popularized by Victoria Flat Earth, British Columbia, I think.
What?
Talking smack and refusing to come in when offered to come into a live chat. So, all right. Yes,
No
Stringer News
way.
1, I think we are getting the Viki treatment.
His name's Viki Falcon because he likes editing wikis. But that's interesting to know. I didn't know that.
All right. People see your PowerPoint.
All right.
There it is.
I hope I did it up well.
Your
I
flurfy
only had
presentation.
I only had a few hours to sort of whip it up. Now when
That's
I'm
a huge
screen sharing,
investment to get the back of your Viki Chicken roommate. Wow.
so I have a question to ask you actually about screen sharing. If I open up another tab like Google Chrome or something, like if I wanted to look at the chat, it won't show that, right?
Give it a shot. I think you're just sharing a window, so I won't see anything else. But give it a try, and I'll let you know.
Okay, I'm on Google Chrome right
okay.
now.
No, I don't see that. So
You only see a PowerPoint?
No, yeah, just PowerPoint. So you did it right.
Okay. Alrighty. Yeah, because okay, I see it now. I see the PowerPoint. Okay, yeah. Sometimes I like to look at the chat, see if anyone says something funny.
Well, there's a lot of people. Given Wikipedia, did Viki catch the avian flu? Wiki editors should be called Vikings. Man, they just keep flowing. Viki is very emotional right now.
That's I saw a lot of good bird puns like before the stream started too.
Yes.
So
all right.
Anyway, so I had a little bit of an agenda. So
Man.
I got some stuff. So I just the first thing I want to talk about is I want to talk obviously his model. But then I wanted to go into his insights that he has on quantum field theory, because yes, Flurf thinks he knows what he's talking about in quantum field theory. But an interesting turn of events is I think I've been brainwashed by a Flurf. No, don't worry. I don't believe that the Earth is flat. But he said a few things about quantum field theory to me that may have been a little bit convincing to me. And I'm kind of scared about that.
Wow.
So I may need your help to get me back on track with that.
All right.
And then lastly, I had an interesting idea. I was thinking about, other things to talk about. And I sort of, I realized I had this idea and, I might as well give it a go if there's time afterwards, of course.
All right. Yeah.
So anyways, I think I should start off with his model. So here is his, okay, there we go. So here's his model, basically. So it's a little different to that of most flat earthers. So in the normal flat earth model, there's just a flat earth, and then there's like a firmament covering it. And there's debate over like what that is exactly. Is it literally made out of glass, or is it made out of ether, or like what is it made out of? I don't know. But in this guy's model, it has multiple firmaments instead of just one, which are layered on top of one another. And sometimes the celestial objects like the sun, the moon, all that, the stars, they're sandwiched between the different layers of the model. So, and yeah, he does use the ether. So he's one of those guys. He doesn't actually believe there's like glass domes or anything. He thinks there's this sort of dark matter kind of fluid that sort of is able to stay in the sky somehow. And so, anyways, it can this ether can form sort of a crystal structure in sort of a way, and it can redirect light on a way based on this crystal structure. So what is the premise of this guy's theory? Why is he adding more like complexity to this theory? How does he think this will help him? Well, his main premise is going to be a common theme in this presentation I made. It's called fitting the data to the model. So now normally in science, what we do is we collect data and then we generate a model that fits the data. So this is called fitting the model to the data. So for instance, if new data comes in that disagrees with the model, then we must throw out our old model in favor of the more inclusive and more descriptive one, right?
Yeah.
But what he's trying to do is he's trying to do the opposite of that. He's trying to do this inverse operation. He starts with the basic assumption that he wishes to preserve, such as, the belief that the earth is flat. And then what he does is he takes that as sort of an axiom, I guess you could call it, a postulate or whatever. And then he works backwards to retrofit the data into the model, no matter how incompatible the model and data are. So that's basically what I call it. I call it fitting the data to the model. That's sort of like the opposite. It's literally anti-science, because science is supposed to fit models to data, but instead he's trying to fit data into his model, into his worldview. So now, okay, I think this is the next one here. The next slide. So anyways, in his model, he sees the way the sun should cast light on a flat earth, which he calls pattern A. So I think pattern A is like the top one. So like you see the sun and then it casts like a circular sort of light pattern on the earth.
The magical lampshade is circular.
It's supposed to. Yeah. It's supposed to do that. Like, but what he then does is what does he do? He looks at the way that what the data would suggest, like for a flat earth. And that's this model D for data down below. And so obviously the sun, that's impossible. The sun can't project light and have it curve around the edges of the earth, right? It just can't do that. It's not the way sunlight is casted. So what he does is he finds a function that takes in this circle from pattern A. So it runs it through a math function. So, a whole bunch of x squared and a whole bunch of, I don't know what the exact formula he has is. And then it outputs this at the bottom. So it takes in what should be happening if the earth was flat, and it outputs what we actually observe, like the patterns of light that we actually observe. And then he makes the argument that the firmament is that function, basically. So whatever light goes into the firmament gets refracted in just the right way to replicate this mathematical function. So whatever the sun is doing, it's going to cast the light out, and then this firmament is just going to bend the light in such a way to make it do this curvy pattern thing here at the bottom. So that's basically his model. It's just saying, okay, so the light should do this, assuming a flat earth, but we know it doesn't. Here's the data that says it doesn't. So what I'm going to do is all I need to do is just take a function, run what should happen on a flat earth through that function, and then I should get the data we observe out of that function. And the real basis for this function is the firmament, refracting and reflecting, doing all sorts of whatever it needs to do in order to act as this function. And so, yeah, that's basically what his model does. And that's really is kind of a data fitting the model, because he starts with his model, which is that the Earth it's flat. And then he says, how can I make the data like match that model? And so he has to come up with these crazy functions, basically.
Yeah,
And these functions.
Did he actually create these three-dimensional functions to do that?
I don't know if they're three-dimensional. I think they're two-dimensional, because he works in a two-dimensional mindset.
Many flurfs do.
But he I don't know the exact function it has, but it's pretty, it's not a beautiful function, I can tell you that, because it has to contort, a circle into sort of a crescent shape, right? So you input in sort of a circular thing, and then you get out sort of a crescent shape thing. So it's not very intuitive. Now, of course, what he does using the model is he accommodates things like the sun, the sunsets, the seasons, the day-night cycle. He tries to fit it all in there. Even the motion of the stars, and, which stars appear in the night sky. Like, I'm here on this part of the world and I see these stars, but someone from the other side of the world may see other stars or whatever. And it's all because he has so many firmaments that he can take in any pattern of light he wants and then output any other pattern of light he wants, basically.
Yeah.
And he just so happens to find the function that makes it so that the flat Earth is that it looks like it could be the model. So that's basically what's going on there. But what I wanted to do is I wanted to get into, after presenting his model, I wanted to, because I don't have the full story about his model, so I can't present everything. But what I did want to do is I wanted to get into the mind of the flurf, like sort of a psychology lesson. I don't know. So I was really thinking, and I realized that this data fitting the model is true for a lot of flurfs. Like they have this axiom, right? And then everything just bends around that. They have this, the Earth must be flat, so all these other things must be true. And I think this is sort of what's going on in terms of their psychology and whatnot. So what I wanted to talk about first was, before continuing on with his, the weaknesses of his model, is to talk about an example from history. So I'm sure many of you know about the Ptolemy model, the geocentric solar system. So what happened here? Well, he starts with this axiom and this unshakable starting belief that the Earth is the center of the universe. Many people in ancient times thought the Earth was the center of the universe. And he did everything he could to ensure any collected data that contradicted this was made to fit the model, rather than changing his model to fit the data. So initially, the model was just a whole bunch of celestial spheres orbiting around Earth. It wasn't too complex. And each celestial sphere is associated with some object, some planet, or the sun, or the fixed stars and whatnot. However, then a few people pointed out, they're like, what about this retrograde motion, right? Your model can't really explain that, can it? And so he said, oh, no, it can't. But what I'm going to do is I'm going to make this data, about this retrograde motion, I'm going to make that fit into my model. So he did something interesting. He added a new circle inside some of these main celestial spheres. And so the planets in these ones, they sort of circle around this new smaller circle, which then circles around in the main celestial sphere. And these are the epicycles. And so this is like a good model here for that. And here's all the planets.
Like a spirograph.
And what I wanted to get into and about this is an interesting thing is Fourier analysis, because interesting, you wouldn't think there's a connection between, actual math and, an outdated model of the solar system, but there is actually a close connection. Fourier analysis actually shows that any and all patterns in motion can be modeled with an infinite amount of epicycles. And so I decided to sort of include these really good demonstrations of this on from the Math Channel 3 Blue 1 Brown. I don't know if Have you heard of that?
Oh yeah, I've seen that exact thing you're showing there in the bottom right.
Yeah. And you
Yeah.
can see like, so in the top example, there's only 5 epicycles. So there's this main circle, and then there's another circle there, and then there's a circle inside that circle, and then a circle inside that. It's like a nested epicycle circle. And so you can see it doesn't really, it looks bad. It's not really creating a very fancy image. But if you add enough of them, right, an infinite theoretically amount, then you can get really detailed patterns. You can get, in fact, any pattern you want, any pattern in the entire universe that you could conceive of, you can eventually get that just by knowing all these epicycles and the rate that they rotate. So in fact, here we go. There's in fact, a portrait of Fourier himself using 192 epicycles. So what this is showing is that any data actually that could contradict the Ptolemy model, he could actually accommodate for that data, because any motion involving epicycles can actually, you can just keep adding more and more and more and more epicycles, and it'll work. It'll describe what you're seeing, but unfortunately, it's not going to tell you very much about what's going on, because you're relying on your model being true rather than trying to throw your model away when, Occam's razor and all these other things sort of contradict your model. And so that's why we had to change our perspective when, with thanks to Copernicus and other astronomers, we were able to move on from the geocentric model and stop adding epicycles.
Yeah, because there's no plausible mechanism for those epicycles.
No, it's just, that's the way it was. That's God created each celestial sphere, and that's how it was. I think that's how it explained it. I don't know how Ptolemy explained it, because he's Greek, he wasn't Christian, but
all right. So
know.
Judy, you got this. Says, I'm seeing the circles and vectors in the top model. The bottom model looks completely unrelated. So if I can offer my explanation for Judy and others like her, so when you draw, use a sine function or cosine function, it goes up and down in these cycles. And if you add another sine function on top of it and add them together, you can and shift the offset and the magnitude, how big it is. You can cause it to the addition of those two together to take a different shape. And in fact, it's used, they do fast Fourier transforms when doing digital communication. You add together a whole bunch of sine waves, and so instead of getting a curve, you get a more of a flat top and flat bottom to the curve, so that it's more of a solid 1 or 0 essentially in your interpretation. So, but there's other ways to add together Fourier curves. So that top one there is an approximation using just 5 concurrent sine waves to do a picture of Fourier himself. And the bottom one is 192 of them. And when you sum them all together, you can force an output like that. So there you go.
Yeah. And I think you can, I'm not very good at, I'm better at math probably than my Flurf buddy is, but
if you can do middle school math, you are better.
Okay. But yeah, I'm not exactly sure how like sine waves, like they turn into circles. I'm pretty sure it's like a parametric sort of thing. Like there's something called parametric equations where like if you said x of t equals to cosine of t, and then y of t equals to sine of t, and then that creates a circle, I think. So maybe that's how it works. I don't know. What was it? Let me go back to what I was talking about. Yeah. So anyways, wait a second, I think.
People are sad that Uranus isn't in there.
Yeah, wait a second. I have to I need to mute for 1 second. Sorry.
Okay. Yeah, I don't know. Uranus is missing, and so is Neptune. Are you sad that I didn't pronounce Uranus differently? Look, I say Lake Titicaca. I can't also go with Uranus the other way. I just can't. In fact, Uranus is the only planet that's named with the Greek name instead of the Roman name. Think about that, people. First one in the chat wins. What's the correct name for Uranus if they stuck with the same pattern?
I don't know. I'm back though.
All right.
Is it Oranos? I don't know. I don't know my mythology. Okay.
No, that's still the nope, it's not. It's no, people are guessing wrong. No, people don't. Oh my goodness. Everybody's got, it's not Clivey. It's not Baccidus.
Baccidus. What the heck is Baccidus?
It's we're looking for the Roman name, not the Greek name. Somebody actually typed in Greek letters. Doctor Who Design typed in the Greek letters for Uranus. No, it's not. I mean, you just got to go to the Wikipedia site. That's where you find it. It's not Cronus. Kalis. There you go. Obi-Wan gets it. Kalis. I think that's the first
Kalis.
one. Kalis.
That almost sounds like a Klingon thing. I don't know if you watch Star Trek.
Oh, yes. The Beacon of Kalis. Absolutely. I used it in a video just 2 weeks ago. So,
anyways.
Yes, and neither is it Bigus Dickus. Or his wife. Do you know his wife? Incontinentia buttocks.
Anyways, I'm trying to find where I was again in my presentation. Yeah. Oh, yeah. I wanted to go into stuff you can't explain because, no matter how, even if you add 1 million epicycles, there's still going to be the flat Earth is just such a model that's just so far from reality that like no matter what you do, it's never gonna work. No matter, even if you have a way to add 1 million epicycles, you're still gonna be far because there's still gonna be so many other things, right? So even if you solve the light problems, like, you solve where all the light comes from in space, there's still so many other things that it doesn't explain. Like, for instance, gravity. He can't really explain that. Now, in addition, we've got, this boat that's behind the horizon.
Yep.
Because remember, light in his model, he perfectly explains, or quote unquote, perfectly explains light in his firmament model. But that's only light coming from space. When it comes to light, in between points on Earth, like for instance,
there's no domes between
the boat and us.
Yeah.
He can't explain that. And then obviously, there's a lot of stuff too, like with the southern hemisphere. And then I have a model here where there's like an airplane flight. Like he still can't explain why airplanes take, weird routes, like when you have them on a flat projection. But those routes do make sense when you talk about a globe model, because that's just the best and most efficient way to get to your destination on a globe. So he can't explain any of that, and I'm sure he'll try to eventually, but I I highly doubt there's any way you can explain any of this. Now, believe it or not, he has tried to attempt to sort of quasi-explain gravity. He doesn't think gravity is an attractive force. He actually thinks it's a repulsive force. So let me try to explain a little bit about this. So in his mind, attraction and repulsion are just they're the same thing, but from two different reference points. So like your attraction could be my repulsion or something like that. I don't know if is there an actual physical, like, is that actually something in relativity or something? I don't know, but in any case, he thinks that, I know there in relativity, there's the acceleration, like acceleration and gravity, there's the equivalence principle. But anyways, he thinks that there's a constant shower of ether particles.
Wait, tell them they're called pushytrons.
Pushytrons. But he thinks that the firmament is constantly raining down at parallel or perpendicular to the Earth's surface, a uniform distribution of ether particles. And so the reason why there's gravity is because all these particles keep colliding with the tops of all these objects, and so pushing them down onto the Earth.
Well, won't the roof of my house did it block that? The pushytrons can't get to me. I got the roof on. Seriously, I mean, you can't see. You're gonna have to trust that there's a roof above me.
And also, the main thing I brought up to him was, if these ether particles are etherious and can't be detected, then how do they interact with our electromagnetic structure in order to actually push against it? And he couldn't explain that. It's like, it would be like proposing dark matter, but then saying it interacts with electromagnetism, even though it obviously doesn't, because we would have detected it already.
I suppose pushytrons get their force from the Higgs pushytron, which is the granddaddy Papa Flurf pushytron.
Oh my gosh.
Okay.
Anyways, but yeah, so those are some of those things that he, even with a million or infinite firmaments, he still isn't able to truly explain. But what I wanted to talk about next is I want to talk a little bit about, I wanted to take a tangent into quantum field theory. I know it sounds like a random tangent.
And this is well, I have one before we do that.
Okay.
A question from Holy Smalls, who's have a little skepticism here is leaking in. It says, question: why are we listening to Viki pretend to, 1, not be himself, and B, be a flurf? Not be a flurf. So Holy Smalls is accusing you of being Viki. And
being Viki, but like pretending to not be Viki.
Yep.
Yeah, no, don't worry. By the end of this, you'll see that's not true.
All right.
But I think that is. But again, this is the internet, right? Anyone's anonymous. You don't really know, like who's doing what.
Sean Hawkins on his Grindr account looks totally different.
He has a Grindr account.
I know. I just threw him under the bus.
Oh my goodness.
I actually couldn't remember the name of the first one. I was gonna say the other one, but Grindr came to my mind. Tinder.
Oh, Tinder. Okay. I think Grindr's the gay dating site, right?
Yes. So sorry, Sean. All right. Microraptors on Grindr though. Anyway. All right, all right, I'll stop. Let's hear. So is this your modifications and questions about quantum field theory based on input from Viki?
Yeah, so he and I were actually talking the other day, and a few things he said made me sort of question things. So I just wanted, what by the way, first, what's your like kind of background in quantum field theory? Like, would you say you're knowledgeable on the subject? Or?
I have a cursory knowledge.
Okay. Well, I mean, no one truly knows quantum mechanics. I mean, even Feynman, that's like one of his quotes, right? Like, if you say you understand quantum mechanics, then you don't understand quantum mechanics.
Yeah.
I just remember that being something, I don't know.
I think that's a paraphrase of it. It's the ideas there.
Yeah. Okay. So yeah, I was talking to him, and he was telling me some things about quantum fields theory that, it kind of piqued my interest. And I know that he's coming from the wrong place and that there's probably wrong ideas here. But I wanted to know exactly what it was that he was wrong about, because unlike the flat earth, there's some things that actually convinced me a little of what he was trying to say. So anyways, now so basically here's the story. So earlier, I think yesterday, I was asking him about his model. And he himself noted that his theory was what he called an infinitely adaptable theory.
Oh, that's
so
convenient.
I know. In his words, an infinitely adaptable theory is any model that can be adapted to fit any data, no matter what that data is. So in the context of our discussion about fitting the data to the model, this is a model in which you can almost always do that. Like, so it's a model where you can always fit the data to the model. So that's what, and obviously it makes sense, right? Infinitely adaptable. No matter what data you get, you're going to be able to adapt your theory to fit that. So now his model is infinitely adaptable to the perspective of light coming from space. Any new data that contradicts his model can be retrofitted by the modification and addition of firmaments. You can also argue that Ptolemy's theory, due to the Fourier analysis I told you about earlier, is also infinitely adaptable. You can always add an epicycle to describe any shape you want. So then I revealed the main flaw in every single infinitely adaptable theory. So here's the number one flaw in any theory which claims to be infinitely adaptable. Every infinitely adaptable theory is also, by definition, also non-falsifiable, right? If any data can be fitted into the model, there's no way you can disprove it. Like, any data that disproves it then proves just another variant of that model. You just adapt your model to fit that. So anyways, I told him that. I was like, your model, it's not scientific. You can't work with it. But instead of realizing his error, my friend just confidently said, "Yeah, sure." So Fleur.
So it's not science.
Yeah, but nice. So I asked him why it was okay, right? I really wanted to get to know what's going through his mind. So I asked him why it was okay for his theory to be non-falsifiable, and here's what he told me. He said that he can do that because real scientists do that. So now, of course, a theory being non-falsifiable is against science by definition.
Yeah.
Science is about making testable predictions. That's not, so you can't have a non-falsifiable model.
By the way, everybody, that right there convinces everybody. There is no doubt. This guy that we're talking to is not a flirt.
Yeah. So anyways, thanks for that clarification. So I asked him why he thought this, that like, what's your evidence that real scientists are using non-falsifiable? Oh, man, I keep messing up my words. But what's your evidence? And so he cited quantum field theory. He was like, that's non-falsifiable. And I said, hold up there, hold up. I may not be an expert in the field. I may not even have a cursory knowledge of the field, but I know it's made many testable predictions. Quantum mechanics, predicted antiparticles before they were even discovered, for example. Yeah. It's predicted many examples of mesons and hadrons in the so-called particle zoo. And it's even predicted the Higgs particle well before it was actually discovered. I think it was discovered in 2014, but like it was predicted in the 70s or something. I even mentioned that, our current models is technically already falsified, right? By things like dark matter, dark energy, matter-antimatter asymmetry. None of those things occur in our current QFT model. So which means it must be wrong, right? At the very least, it's incomplete, but we already know it's wrong, right? So obviously it's falsifiable. So I asked them, why do you believe that this is non-falsifiable? And so he told me, this is what he told me. So obviously I don't know, I can't remember verbatim what he said. I'm paraphrasing here. But he told me that I wasn't talking about quantum field theory. I was actually talking about the standard model. So the standard, and then he tells me that the standard model is just but a manifestation of QFT. So sort of an excerpt from it. an individual model within the larger framework of quantum field theory. So while the standard model may be testable, its basis and foundations QFT itself is non-falsifiable. So basically what he told me is he's creating a distinction between quantum field theory and the standard model. And I'm not fully convinced. I don't know. Is that true? Who knows? I don't know enough about this to be able to answer that. But what do you think, by the way, before I move on? Like, are they two separate things, or
the version of quantum field theory that we understand versus the superset real understanding of quantum field theory?
Well, the difference between QFT and the standard model. Like, what's the difference between the two?
I think the same thing? I think they're both, the terms are probably not super rigidly defined.
Okay.
So, I mean, the standard model of particles is, I would say, part of quantum field theory. So just, you know, our understanding of the particles within quantum field theory is the standard model of particle. I don't know. I don't want to go too far into this. I can't split hairs on this. Yeah.
Yeah. I do know that occasionally in your chat you have like a scientist about what's his name again? Clive or something. I don't remember.
Clive Wells, he's here.
Oh, he is? Okay.
Yeah.
Yeah, I don't know. Maybe
so you've watched some of the videos.
Oh, I follow your channel quite closely.
Okay.
Oh, so yeah, I've seen a lot of your your flat Earth.
So you're not just the random roommate.
No, okay. No. In fact, I was the one who introduced my floor friend to you. So that's how it happened.
I see. Was he he was in the chat a week ago?
Yeah.
Was that the first time that he participated?
I believe so.
Okay.
I don't know. I told him about it a few weeks ago. So
okay. All right. Clive Wells says hello.
So yeah. Anyways, so I think basically what I can probably tell is my friend has an incomplete understanding. You know, he's probably all these flurfs. They have confirmation bias, right? They look at information like a Wikipedia article, and then they only pick up what they think they want to see, right? They don't actually read the full thing in its entirety. So I think he has an incomplete...
they think that their view of it, the small part that they read, is the full understanding that all humans have on the topic.
Yeah. So I think that's the problem here. But the thing is, the dangerous thing is, his misunderstanding can be spread. It's kind of contagious, right? Because he can prey on my own inability to understand the field, to sort of spread his ideas to me. So that's kind of what I want to sort through here. So anyways, so then I asked him, this is the next part of the story. So I asked him, so can you tell me more about this distinction between the two? And so he was telling me about how the standard model was created, or at least how he understands it was created, which is probably historically incorrect, but I'll tell you what he said anyways. He told me that it began with QED, so not like the math thing, Quoto, Era, Demonstratum, or whatever it is.
Quantum
electrodynamics.
Yeah.
A very successful field theory that explained mostly everything when it came to forces, other than gravity at the time. Then he asked me what happened when the strong and weak nuclear forces are finally characterized. So obviously we knew there was something other than electromagnetism, even while QED was being developed, right? We had, how is the nucleus able to stay together when the protons should just blow each other apart, right?
Yep.
But we didn't know what that was, so because it wasn't fully characterized. And so unlike antiparticles and so on, these forces, they were nowhere to be found or even implied in QED. So what he was telling me, and I don't know if it's right or not, because he has bad ideas, but he told me that if you make a minor change to or I don't know if it's a minor change, but if you make some sort of change to the Schrodinger equation, and then you do this with it and that, and then you make it like symmetric, or I don't know, like you can get equations that describe quantum electrodynamics, or at least the basics of it. Like you get something that looks like an electrical phenomenon. So I have no idea if that's true or not. He could be pulling something out his butt. But he uses that to then state you can't do that when it comes to quantum chromodynamics and weak nuclear force and all that other stuff. So then he uses that to go on and say that because these forces, the only reason that they're characterized as a quantum field is due to how successful QED was at explaining electromagnetism. So that's what he believes. And then at this point, and then here's sort of his thesis. His thesis about the Standard Model is that it's stapled together. He thinks that this model that's sort of been a pinnacle of our understanding about particles and their dynamics and interactions, he thinks that it's a stapled together mess of a whole bunch of disparate ideas that have just been crammed together by physicists. And he told me that when the only reason that because you can't extend whatever the Schrodinger equation or whatever, the way you can with electromagnetism, apparently, to quantum chromodynamics, the only reason why you're able to have a theory of both quantum chromodynamics and quantum electrodynamics is because we first observed this quantum chromodynamical behavior. And because we observed it in nature, it must be also in our equations too. So what the scientists then did is they said, okay, so we know QCD must exist. So let's just cram QCD and QED together to smash them together to create a new theory that encompasses both of them. So that's his understanding of how the Standard Model was built up. And I can definitely tell you that's probably not accurate.
Yeah,
I can tell you that right off the
history of how that was figured out, I think might be something worth studying for him. It's my understanding. QCD came by a bit later, and it was Feynman who was primarily responsible for that, as I understand it.
Mm-hmm.
Where the other stuff before that was other people, a collection of many other people.
Mm-hmm.
I don't know. It was, I can tell you, what actually got me into this silly topic was listening to lectures on quantum physics on YouTube. So I'd spend, I'd just search out different things to listen to, and YouTube figured out that I liked science. And at the time, flat earthers had tricked the algorithm into thinking that they were doing science because they used sciencey terms. And so it started feeding me not flat earth stuff, fortunately, some anti-flat earth stuff like Slice Barkane and Simon Dan eventually. So
yeah.
Anyway.
Yeah. So anyways, but that's what he believes. My friend, he honestly believes that this very important model is just a cobbled together sort of theory. And then he uses that to continue on with his argument. So
to say that he can do that elsewhere. Is that kind of his justification then? Like he says, yeah, I can do the goofy thing that I'm doing because I assert that QED is doing the same type of thing.
Yeah, okay. I forgot to be catching up on my PowerPoint. I was just reading my notes. Okay, I think this is the next part here. Says this is, quote unquote evidence of his position.
It's complicated, therefore fake.
Pretty much, basically that. So what he did was he showed me a picture of the Standard Model equation. So, and I have never seen this before. So I was kind of horrified. I was like, oh, wow, that's a pretty scary looking thing.
Yeah. Have you done calc?
Me? Yeah.
Okay.
I've obviously I've done calc.
What
But
people were wondering what your background is, if you don't mind sharing.
oh yeah, okay, I'll get into this later, but my background is actually in biology. It's not in
Okay.
physics or math or anything like that. But I did have to take some basic, math classes when I was in university.
Yeah.
So but that was a while ago. So um anyways, so he showed me this. And so he was like, scientists, they're always talking about how beautiful the standard model is. But as you can see here, does that really look beautiful to you? And I said, well, I mean, I don't know. I mean, isn't beauty subjective? Isn't beauty in the eye of the beholder? You can't really use beauty as an argument for
Yeah.
physics,
The
right?
metric
Um,
is, does it work?
yeah, it's a human thing. It's not a universal sort of. But anyways, and he said, well, this is just a whole bunch of mathematical terms added together. This term plus this term plus this term plus this term. And all these mathematical terms just added together because that's just a combination of those terms that happens to match things we observe in nature. So he's like, this is basically this is the very evidence that the standard model is just a whole bunch of stapled together concepts. Like he's basically saying scientists are like, oh, okay, there's something in nature that has to be in our model. There's something in nature that has to be in our model. There's something in nature that has to be in our model. And then what they do is they then add these things together. So they create a mathematical term to encapsulate what that thing is that they've observed. And then they just staple it on with an addition symbol to their standard model. And he says, in fact, he goes on and he says that scientists are doing this today. They're actually still doing this. And here's some of the examples he's given of that. He states, let me see here. What was it again? What was the example he gave me? I'm thinking about this. Oh yeah, dark energy. Where was this again? Yeah, here it is. What is it? Yeah, dark energy. He says that some scientists believe dark energy is this field called quintessence. And this quintessence field is, a particle field, like any other particle field. So, and then if quintessence was discovered, he argues, then what scientists would just do is they would take the term that describes this quintessence field and they would add that to the standard model. They would tack that onto the standard model, staple it together. Quintessence, we observe it to exist. So therefore, just add that on, cram that into the standard model, with an addition symbol. Now, obviously, we haven't discovered it yet, but this is hypothetical. Like if we were to somehow discover quintessence was actually how dark energy works. I think there's also one other model for dark energy. It doesn't rely on a quantum field, like it's a 0-point energy thing. I don't know. I don't know what I'm talking about here. So
All right, if I could say and maybe partially address Viki here,
okay.
You form a hypothesis and then you make predictions with it, right? That's the science. That's the falsifiability of it. So yes, you can propose quintessence or something that answers the question, why does the universe appear to be expanding when everything else suggests that it should be contracting? So you propose that, and then you model it, and then you say, all right, what's going on? And then you need to have some sort of a plausible mechanism that's causing it. And so you test that. A better example, because it's in the past now, is neutrinos. People were examining these reactions and the particles, and they said, oh, hold on a second. There's a small amount of energy that's unaccounted for in this interaction. Why? Well, there were some other things that people proposed, but one person proposed, well, maybe it's a particle and it's got some small amount of energy and it's just going away. And that particle doesn't interact even often with other things because of it's very small and it whatever, it's got these particular properties. So that was a falsifiable hypothesis for it. And they tested that, and I don't know for sure, but I presume that they tested other of the explanations for it, and found, yep, there does seem to be a particle that matches the description that was proposed for it. The difference is with that and what Viki's doing is that there's a plausible mechanism, it's testable, and it was tested and confirmed. And if it was tested and not confirmed, they would have said, well, that was a dead end. Let's go somewhere else and figure out some other thing.
I see. So now, all right, that's an interesting perspective. So let me see here. Where was I again? Oh yeah, with dark matter. He also he loves to bring up dark matter as an example of this. So he says that the most natural way to add dark matter into a Sarah model is with something called an axion particle. And he says that for some reason that works nicely with like a strong nuclear force equation or something. I don't know what he's talking about. But if it turns out that dark matter is something else, other than axions, like a WIMP, a weakly interacting massive particle, those are not predicted or even hinted at by the standard model. So if those are what dark matter actually is, and we finally discover that, then physicists, to incorporate them into the standard model, would have to create a new field, right? Quantum field particles are just fluctuations in a quantum field, localized, whatever. And then they would take that field term and then they would add that onto the rest of the terms in the standard model. Like that equation that I showed you earlier, like they would just create a new addition symbol and then add the WIMP field into there. Like that's what he thinks would happen. I don't know. Is that what would happen? Who knows? I don't know.
They
physics.
Would propose something and see if it, then test it. Yeah.
And then he goes on to say that if we were to try and create a fictional universe with different laws of physics, QFT would still work just as fine in that universe as in our own. So for instance, if our universe had different coupling constants, particle masses, even if the strong force had 4 color charges rather than 3, there would be a model of QFT, some sort of counterpart of our universe's standard model, which could still be invented to account for all that. So that's what and he uses that to lead right into his main point. So now you can probably see what this is building up to, what his argument is building up to with all his evidence.
Do you have slides for these?
Let me see. Oh, this is no, this is another thing done in the future. Yeah, I know. I cobbled together this presentation, a few hours ago. So I only had a few hours after he chickened out to compile this together. So anyways, he arrives at his conclusion, which is that no matter what universe we live in, what laws of physics there are, what new data we discover, he argues this data can always be made to fit the model, where the model starts with the unshakable axiom that everything is made of quantum fields. So in other words, the main point of his argument is that quantum fields theory is an infinitely adaptable theory, and that's not falsifiable. Because any universe, any situation that you can imagine, any new addition, anything we observe, you can always just explain it away by adding a new quantum field. So basically what he's proposing is he's making an analogy to the Copernicus model, right? Something doesn't match the geocentric model, we just add a new epicycle. My friend believes something doesn't match the physics model that we have, just add a new quantum field, epicycle, it's all the same. So that's his main thesis, is that quantum field theory is an infinitely adaptable theory because no matter what data goes against it, we can always explain it away by adding a new quantum field to account for that data. We can fit the data to the model. And that's his main point. So
and he misses the empirical confirmation part of it.
I think that sounds like that's the main problem, right?
Yeah.
With his understanding of this. But So that's an interesting point, though. We can confirm, certain particles. Yeah, I'll bring this up later on. I think it's later on in my presentation. But yeah, that does seem like a. um, all right. So let me see here. What was
I've Eddie Reese is wondering, is your flirf mate often late with rent?
late with rent? No, not
Okay.
really.
He's gainfully
Um,
employed?
yeah, thankfully not at a scientific job though.
All right. All
That
right.
wouldn't be good. Um, so anyways, so that's an interesting point. So I mentioned, so I was like, I was trying to I didn't know exactly how to counter this point because I don't have a good standing in the field. I don't know much about it. So I was like, even if QFT isn't really good at explaining reality, we shouldn't throw it away, right? Maybe it's good at describing reality. It's a pretty good explanation of that. But he doesn't seem to think that either. He seems to think that QFT is actually a really bad explanation or description of reality. It's not only not a good explanation, it's also a really bad description. And he says that it sucks at description due to how complex it is, obviously, anything complex to a flurf is going to be,
Yeah.
they don't like it. Since even trying to approximate it, like on high-powered computers, is so challenging, we need to use some underhanded mathematical tricks to get everything to work out. And so he introduces perturbation theory and something called renormalization. And I have no idea what these are. I have no idea what it is, but he claims that they're underhanded mathematical tricks designed to ensure the math works out when trying to actually use like computers and stuff to model, quantum field theory and stuff like that. So he argues that why would we use such a complex model of quantum field theory? We should discard it, right? If it's so complex that even you can't even model it, right? Like, like fully accurately. Like I don't know if he thinks we live in a simulation or something. He seems to think that if computers can't model it, then it can't exist in reality. Like, and I don't know, maybe who knows? I don't know. Like, but that seems to be his point of view. Like, why is it possible for something to happen in reality when there's no way for us to be able to use computers to model that thing like completely and fully accurately? So I mean, it would make sense from a simulation hypothesis perspective, because obviously in the simulation hypothesis you need to use models to model reality like perfectly. But I don't know. And he also cites other problems with quantum field theory. He doesn't like how quantum field theory confuses artificial mathematical terms for real phenomenon. So he believes that many symmetries in the standard model are artificially introduced only so they can be fixed by adding a gauge field. So like he seems to think that he wonders how the artificial introduction of some sort of local symmetry into the universe mathematically can cause the real effect of a gauge boson's existence to occur. So and I'm just talking to you about this. I have no idea what I'm even saying. This is just what he's told me.
Okay.
Do you know about symmetries and gauge fields and all that fun
Not
stuff?
not
Like,
not a lot. And yeah.
okay. And then he also cites other things like a vacuum expectation value and spontaneous symmetry breaking as other times when artificial mathematical introductions can apparently, according to him, cause real
Sounds like
effects.
he's heard some buzzwords. Might he be a fan of Ken Wheeler?
Oh, Ken Wheeler. I know. Isn't he the counter space guy? He's always coming up
Yes.
with word salad and techno babble and stuff.
Yeah.
Okay. Maybe, I don't know. I don't know what he watches on YouTube. Other than you, of course. And
Microraptor thinks you sound like the guy from Action Lab. Are you from the same area, or maybe related, or the same person?
Me? I'm the guy from the Action. What is
Action
the
Lab.
the
Yeah.
Action Lab? Isn't that the
YouTube
I think
channel?
I've heard of that channel before. I don't watch it, but like I've heard of it.
All right.
I don't know.
Plausible
Maybe I
deniability. I've never seen you in the same room as him.
yeah, yeah. I don't know if I sound like him. I do have a very, though what I would consider a very distinctive voice. Like if anyone watching the stream like knows me in real life, and I doubt that, you know, the world's a big place, so it'd be a mighty coincidence. They would instantly know who I am. They'd probably have already texted me saying, "Oh my God, why are you on this guy's stream talking about flat Earth or something?" But yeah,
We got a few people that say, "Oh yes, he totally sounds like Action Lab guy." Now that you say it, and some people are saying no. So hit or miss.
yeah. When I've shown, I often have you know, pictures like of someone who looks like someone else, and then I say, doesn't this person look like this other person? Like they could be doppelgangers. And then sometimes they're like, yeah, and other times they're like, I have no idea what you're talking about. I think it's because, you know, everyone's you know, facial recognition and I guess speech recognition, you know, the neural pathways, they're just wired differently. I don't know. I'm not a I'm specialized in cell biology, not neurobiology, but so maybe that's what's going on. I don't know. But in any case, I'm less convinced of these points. Like for instance, going back to what my friend was saying, how does he know that QFT isn't actually the simplest way to describe the universe mathematically? Like, how does he know that it isn't? Like he's saying, you know, it's so complex that even computers can't model it without underhanded mathematical tricks. Well, what if it just so happens that QFT is the simplest way to describe reality? What if there isn't a simpler way to doing it? He doesn't know that. I mean, there could be, you never know. But he doesn't know that. So, you know, in any case, I don't really know enough about the math behind QFT to challenge his points about the artificial, you know, like math physicists introducing, you know, artificial
My guess is
math terms.
he's probably just repeating somebody. Like, does he have a hard science background?
Well, he doesn't have any science background, so, but isn't that par for the course?
It is. And kind of academic stolen valor tends to be popular too. I've had several people claiming to be engineers that actually weren't.
But yeah, but even people who are experts in something and who have an actual science background, they can, if they go outside their field of expertise, they can still, you know, get things really wrong.
Oh yeah.
Like for instance, I saw a video from this guy named Professor Dave. Professor Dave Explains.
Yep.
And he was talking about this guy named Pierre Marie Robatobo or something. I don't know what his name is. But he's a guy who actually published a lot of papers and is quite well known for radiometry or whatever. But then he stepped outside his field of expertise to start talking about the CMB and metallic hydrogen and stuff. And he's way out of his element there.
Who
and
did
also
it?
another comment.
Dave did, or the guy Dave was talking about?
The guy Dave was talking about.
Okay.
And
well, it happens. Also it happens all the time. Sabina Hassenfelder has done videos on 5G, and she got it all wrong.
Yeah, I mean, I do watch Sabine. I watched that video too. But I actually was watching a video thinking you were debunking another one of Sabine's videos. Did you know that Sabine actually was able to get away with publishing a video where she argues that a moon of Saturn is a quantum object? I laughed my butt off during that video.
Did she?
Yes.
What?
She actually thought a moon of Saturn, Hyperion, a moon of Saturn with an enormous mass is a quantum object. She actually thought that, like in a video. Like I swear, I'm not making it up. You haven't seen that video?
No, I
I don't know what the
Yeah,
title
I
is.
haven't watched a lot of her videos.
Yeah, but just like go onto her channel and like go to the search bar and look up Hyperion, and I think maybe it's probably the first thing that'll show up. But
Okay.
yeah, she's like, oh, this the reason why the chaotic motion of Hyperion is, there's quantum weirdness going on and all that. It sounded pseudo-scientific to me. And I even tried to like send her a super thanks or whatever. You know those little heart buttons like where
Yeah.
you can pay the money, but she never got back to me. I was like,
Oh,
this sounds.
she doesn't talk to anybody.
Oh, really?
Yeah,
Even if you give her money, she won't talk to
I
you.
don't know about that, but on I have an extension installed in Chrome, so
Mm-hmm.
I can search comments. And there's just a button on videos to see all of the comments made by the author of the video.
Mm-hmm.
So it's easy to go and just go to one of her videos, and one click I can see all of the comments that she's made on a video.
And she never makes any.
She tends to make a couple, not zero. I've not seen zero. But the
Okay.
5G video,
Mm-hmm.
two. One was okay, and the other was some other passing comment. That's it.
Do it on actually do that extension on the Hyperion video. I'm curious to know
Okay.
how many
I'll have to
comments.
look.
I don't know.
Somebody wants me to show you a book cover.
A book
My
cover.
Microraptor. But also, holy smalls, people are putting the screws to you here. Says, how did Viki mate Jonathan here know how he had a few hours to make this PowerPoint? How did he know his friend wasn't coming back? He seems to be surprisingly prepared for just being a roommate.
But I did say he canceled earlier in the day, so I had a few
Yeah.
hours to whip this app.
Okay. All right, hold on.
It's a tinfoil Tuesday or whatever here.
Well, somebody's also a fan of Simon Dan, I see.
Yeah, I watched so many debunking videos. It's silly. This whole community is so my favorite part about this community, like every single person in the community, I mean, maybe not, I don't know if Simon Dan, yeah, kind of. They all like I don't know how to say it. I wouldn't call it they're all like gloaty like towards the conspiracy theorists. I don't know how to another way to say that, but like they're all like, I don't know, but I just love that because it's so funny to watch them just gloat at the conspiracy theorists, and the conspiracy theorists are always like, oh, it's so funny. I don't know if you know what I'm talking about, but
Yeah, I do. And it makes sense, right? Because the flat earthers are just, I mean, they're aggressively dumb.
Mhm.
And they're just oblivious to any sensibilities at all. They're so thoroughly convinced of their we know everything position. All right, I'm gonna stop your share because I want you to see. Are you watching the stream?
Yeah, wait, I can, yeah, I can't. I'm
All right.
going to the
All right, I'll just.
oh, not Vicky, it's his roommate, Vicky Chicken Down.
Yeah, there you go. All right, here's from Microraptor.
Okay.
Is this the one you wanted, Microraptor?
Everybody poops.
This is the it's got Michael Curvature Toon, Craig WTF McNeil, and Simon Dan.
Simon? I don't think those are their real names.
I can tell you for sure that my middle name's not Curvature.
Was this written by a flurf?
No, this is Microraptor. Yeah, all right. Microraptor says that's it. I don't know. Microraptor wanted you to see that. So there you go.
That's pretty funny.
All right, I need to
Let me go try to see if I can Sabine Hassenfelder YouTube.
I can, yeah, I can
Chaos.
actually, I'll pull it up right now.
Oh,
So,
the video is called Chaos. Let me see. I'm okay, good. I'm still muted on YouTube. I don't want like the video to start playing. Chaos.
yeah.
The real problem with quantum mechanics. It's called Chaos, the real problem with quantum mechanics. So I don't know. You can I don't know. I thought it was silly, but I'm gonna give her the benefit of the doubt and say that the video is a thought experiment, but that she forgot to frame it as a thought experiment.
Yeah.
So in my mind, her only mistake was the framing of the video. Like it's like she's presenting an absurdity, like a Schrodinger's cat, Schrodinger's cat's an absurdity, and it's a thought experiment, right? So maybe she's doing a similar thing, but to illustrate a point about chaos in quantum mechanics, but she forgot to say, the most important part of the video, which is her arguments are all based on a thought experiment, right?
Yeah. All right. Let's
Yeah.
see. 0 comments from her. Oh, it's not done loading.
Okay.
It takes a minute. It loads them all.
That's a really cool.
So Zoomy is saying, does Viki think that he's debunked the Hellman-Feynman theorem? Which I don't know what that is.
Me neither. The what? Behind
the Hellman-Feynman theorem. This is from Zoomy the Tomato. So, let me read the quotes here from the book review. It says, "Now I can navigate both planes and poop," from Alyssum. We've got Meow from Turtle, Raccoon, and Dave. And then we've got the final quote, "Who let these people into the space station?" from Scott Kelly. Astronaut Scott Kelly. So.
It says in quantum mechanics, the Hellman-Feynman theorem relates the derivative of the total energy with respect to, oh my God. I really wish Wikipedia wasn't, I understand why professors would want to write Wikipedia articles to make it, the most accurate. But because, actual quantum mechanics professors are writing these articles, they never introduce it in a way that's clear to a 5-year-old. So, and basically in the context of quantum mechanics, I'm a 5-year-old. I need things explained to me like I'm 5. I don't understand what something that relates the derivative of total energy with respect to a parameter, the expectation value, Hamiltonian, blah, blah, blah. I know that the Hamiltonian is something that appears in the Schrodinger equation, but that's all I know about what the Hamiltonian is. I also know that there's something in classical mechanics called the Hamiltonian, which is sort of the total energy of the system. It's the potential plus kinetic energy. I don't know how that relates to quantum mechanics. Really.
I thought it was just a rap kind of musical.
Alexander Hamilton. Oh my God, that's funny.
All right,
I love that.
It is good. The rap disses are good. So here's a screenshot of Sabina, all of the comments that she had on that one video. 1, 2, 3, 4, 5, 6, 7, 8 comments. 1,873 comments total are visible, and she made 8 of them.
Wait, I can't get to the minimize. Oh, there we are. Okay.
So
I'm going back to oops, that wasn't it. Where's my the YouTube? Okay, there we go. I made it back.
You'll have to ask Viki.
I'm not sure what you disagree with. My point was to say that taking an average isn't a physical process. Yeah, I mean,
yeah,
but that kind of calls back to math versus physics. That's a very common debate, especially with pseudo scientists. And it even kind of factored into my discussion, right? I was telling you, he thought that introducing artificial mathematical terms into a theory to make everything work out and then getting real things out of that, he was confused by that. But I run into a rather unexpected, I don't know what she's replying to that. I don't know what the context is.
It wasn't to read it. It was just to find that She didn't have a whole lot.
Okay.
So, and then here's Quantum Physics for Babies that Safety K sent.
I probably need that because
So,
I'm a baby when it comes to quantum mechanics. I don't know very much about it. There's a derivative here and then a Hamiltonian there and everywhere. Do. I don't know. Okay.
We don't need to make a musical out of it, but Quantum Degreaser.
Yeah.
You're big, if I'm a big fan. Quantum Degreaser says, hearing half my name used so much in the discussion is really making me feel special. Or maybe it's the booze and ketchup chips.
Oh. Well, I mean, couldn't Quantum Eraser say the same thing? And isn't Quantum Eraser a flurf?
Yeah.
Okay. Oh my goodness.
It's my understanding that Quantum Eraser does not understand Quantum Eraser. But
no, I mean, I don't either. Is it the delayed choice Quantum Eraser?
Delayed choice Quantum Eraser. And Sabina, actually, her video on that is really good.
Yeah, I think I watched that a long time ago.
When she's in her specialty, she's very good. But when she ventures outside, makes some mistakes. So
yeah, but anyways, whenever you have time to watch that Sabine video and that I recommended to you, just to see if I'm not.
I have it up. I'll watch it. I'll watch it later.
Okay. So, anyways,
do you have more?
Oh yeah, I've got a little bit more.
All right.
I know. I'm sorry. It's.
Right.
So I think that's good enough for quantum field theory. I really I can kind of understand where he's going wrong with this. He has a surface level understanding and that sort of filtered through his biases and whatnot. Although it does make me wonder if what he's saying is true, if you really can take a quantum field theory model and use it to describe even fictional universes, right? Like, if this parameter was different or that parameter is different or this or that or the other, you can still create a quantum field to describe it. Well, then there's obviously a question here. If quantum field theory, it can indeed be used to explain all these different things. And in order to prevent it from being a sort of falsifiable theory, there would have to be something in quantum field theory that explains why only the quantum fields that exist in our universe are the only quantum fields that could ever possibly exist. Because the moment you introduce the idea that quantum field theory could be developed to describe a fictional universe, then you have to wonder, why aren't we living in that fictional universe? Why are we living in our universe? So I think he's obviously wrong and stuff like that. But I think that quantum field theory still is missing something. It's missing the explanation of why this particular combination of quantum fields with these particular properties are the only kinds of quantum fields that could ever possibly exist. It's impossible to come up with any other combination of quantum fields, except for the ones that we just so happen to see in our own reality, right? So yeah. I don't know. That's the only way I could see quantum field theory like becoming a falsifiable theory, is if there's actually a mechanism that ensures that our universe is the only possible universe you could ever get from quantum field theory. So in which case,
there are people that don't think that ours is the only universe. The many worlds hypothesis is the opposite of that.
Well, I don't understand much about the many worlds hypothesis, but what I could tell from the many worlds hypothesis is it's an interpretation of quantum mechanics where, the wave function, it doesn't really collapse. It just sort of takes on different values across all the different universes.
Yeah.
But in the multiple worlds interpretation, all the universes would still have the same laws of physics. It's just that different results will be measured of different experiments in all these different universes, but the laws of physics should still be the same across all the universes. So I don't know about that, but again, I don't really understand very much about this. I know and I do want to keep emphasizing that, because a lot of these, pseudoscientists who are experts in the field but talking outside that field, they talk with the same authority about that field that they do their own expertise, and that can mislead people. So I just want to avoid that problem with me. It's a courtesy to the viewers and to you and all that.
Yeah.
So anyways, but what I did want to talk about just really quickly is an idea that I had. So I've had this idea for a while. And in fact, I didn't come up with this idea, but my research team came up with this idea. So I'm a, molecular biology. I'm in a research team, and we sort of came together and we're talking about pseudoscience. This was a few months ago. And so we came up with a sort of idea. And I actually kind of, I talked about it already with this dude named Planar Walk. You've heard of him, right?
Oh, yes.
Yeah, I've talked about it with him already, but that was already like a month ago, and I got distracted by my work when it increased, so I had to focus on my actual job. But my work is clearing up again, so I figured I'd at least take this opportunity while I'm talking to you to sort of bring it up. So anyways, this idea is called it's called the I know, sounds like a high stakes, heist operation, right? Anyways,
hold on. Maybe I should put on my slightly larger glasses.
Oh, okay then. Yeah, sorry if the text is small. I try to do my best with the presentation, but I had to whip it up quickly. Anyways, my project is called Pseudomath. So it's the application of math to pseudoscientists. But I can already hear you. I know that pseudoscientists tune math out. They hate math. And there's a lot of reasons why they do. And they just tune it out. Like, they're like, I'm having none of that. But the project isn't to directly confront pseudoscientists with math. That's not the goal. It's to indirectly do it. So anyways, oftentimes pseudoscience and math, they're incompatible with each other. There's many
often.
For instance, pseudoscientists, they don't like math because it's complicated, and they don't like things that are complicated. And then there's also the whole math versus reality thing. A lot of pseudoscientists seem to think that if something isn't actually in reality, then you can't really use it to describe reality. So, they're like, oh, x squared, where in the universe can you find the function x squared? I don't see a parabola in the sky anywhere. Like, so therefore you can't use x squared to model, gravity or whatever, and they go off on all these tangents about that. And obviously that's flawed reasoning. Math is actually a way to, obviously math doesn't exist in reality. You can't go, it's not like Plato's, idealized world where there's actually a physical world where like parabolas and circles and stuff exist. No, that's obviously not true. But it's a good way to put things on a logical foundation, because math is itself on a logical foundation. So when you use math to describe physics, then you're putting physics on a logical foundation too, right? So I think that's sort of why math is so important in physics in general. And there's obviously many other reasons too. It makes modeling physical phenomenon easier without actually having to do, the experiment, right? It's easier to say, x squared causes, describes the motion of this object, rather than actually, throwing the object in that manner, and then whatever. Anyways, I'm going off on a tangent. I do that a lot. So anyways, Also, the less math there is, the more freedom these pseudoscience people have to make claims. Since if they lack a concrete logical foundation, then they can make whatever claim they want to make, you know, and math is what provides this logical foundation. So they want to escape having to confine themselves in that way, you know, because their claims are often illogical. There's no other better way to put it. So then what are the goals of this project? Why would we do this, and how would we go about doing this? So as you can see on the presentation, first I will infiltrate. I will put on my spy gear, and I will like put on a mask, and then I'll put up a rope on my back, and then I'll descend from the ceiling. I know I'm a loopy guy. Sorry.
Tom Cruise. Yeah.
But I will pretend to be a student of their theories. I know they're distrustful by nature, but I'll try my best. And then what I'll do is I'll claim that I have a certain particular learning style through math. So, you know, visual learners, they need to learn by looking at things. But I learn things by just, you know, doodling math on the side, I'll say. So the pseudoscientists, they won't have to do anything about math. Like they won't have to even touch it with a 39.5-foot pole. They don't have to do anything with that. It's all me. I'm doing that. So yeah, that's what I'll be doing. So on the side, while they're talking to me, we'll start from their axioms, and then we'll build up from there. And every claim they make, I will transform this claim into a mathematical statement that encapsulates that claim. And then I'll keep that to myself, you know, put that to the side and then move on. And the end goal is to find a GUT, a general unified theory of their crazy model, some fundamental, you know, equation or system of equations from which all their concepts and worldview about physics and reality and blah, blah, blah can all be derived. And so all their claims that I've already written mathematically can be derived from this big mathematical expression. And so obviously this won't mean anything, right? It doesn't describe any physical reality. It's describing a fictional
would you actually have
reality.
Some equations on there presented? And of course they just gloss over when they see math. And so they would look at that and say, oh, wow, that looks great. It must be true.
I mean, I could do that. But let me get into the main rationale for what like maybe I don't know if that could work, but I think that really depends on the pseudoscientists and how because they're on a spectrum of how much they'll tolerate math and how much they hate it. Like some of them will tolerate it and may even be convinced by flashy figures, but other ones are just like, oh, math up, tune out. No. So, but here's the main rationale for why I would want to pursue a project like this. I think math is often a great insight into how they think and what their thought process is. You know, it's sort of a universal language. By generating the math of the theory, one can easily explore it without being hit by bias and other things, or being hit by word salad. Like, for instance, I think Ken Wheeler would definitely work for his theory, right? Imagine like I subject myself to his word salad for long enough where I actually scarily begin to understand it. And then I use my understanding of that to create a math, expression. But then once I have the math expression, then you don't need that word salad anymore, right? You can just look at what he's saying mathematically, and then it bypasses all that word salad. So it's a good way to explore the logic and the ideas that these people are following in their minds without actually having to interact with them directly, right? You're just interacting with their idea in a mathematical pure form that you can explore without biases and without them telling you, no, that's not what I meant, or whatever. And so in addition, I think having a mathematical model could allow for direction and debate. So I've had an idea where you can convert math into verbal language, which I consider the opposite of what I would do. So like, when I'm being told their ideas in the tutoring session, they'll tell me an idea in natural language. And then it's my responsibility to then convert that into a mathematical expression. But then in order to communicate back to them, I would have to take a mathematical expression and then convert that back into natural language, right? Because they won't hear the math, right? They don't understand that, or they don't care about that. But if there's a way to then go backwards and turn a math expression into a verbal expression, then I think this could be very useful. Like for, so it can provide so direction and debate. And I also think it's good because math adds a consistency to theories. So obviously that's one reason why they hate math. They want to be able to make whatever claim they want to make, regardless of what they've said already, and if it even makes logical sense with what they've said already.
They don't want it falsifiable.
Yeah. But as soon as I come up with a mathematical model, I have a crystallization of their worldview in the form of that equation, at least at that moment. So that means any idea they perpetuate has to be relatable back to this grand unified theory in some logical way. However, if they come out with a new claim that does contradict, then we can do this whole math to language, language to math translation thing, and then point out how what they just said contradicts their claims that they've made earlier. And we can do that precisely using this by doing it mathematically to show the contradiction, and then to translate that expression into natural language to then hit them with their own contradiction. I don't know. Maybe it'll work. Who knows? This is just an idea at this point. Anyways, in this way, we can kind of gain a foothold into their minds and thought process, and we can actually hold them accountable for their own claims and ideas. Maybe just exploring the theory we can uncover certain other math expressions derivable from the GUT that would represent claims that they wouldn't want to promote, maybe. And then we can do the whole translation back and forth. And this would be a good, that like we can present them with these during the debate, and they'd be like, well, my theory doesn't say that should happen. That's absurd. And then we'll be able to tell them exactly in a logical way how their theory would lead to that conclusion, even though they haven't realized it themselves. But I think that my favorite, rationale for this whole endeavor is that it can actually make pseudoscience, it can put it to work for us. So what do I mean by that? Well, so if you remember the discussion of the geocentric model earlier, so while it got bulky with all these epicycles, and that's what led to its downfall, it still required an amazing insight, an astounding shift in perspective in order to replace. So, and throughout all of mathematical and physical history, it's all been about changes in perspective, right? We have to change the way we model or the way we see things in order to better understand things. That's just what I've noticed. And so now in this, an example of this would be, now how would pseudoscience help us with this then, right? Well, it can give us new perspectives, right? So even if these perspectives are wrong in the way that they're applied by the pseudoscientist, they can at least give us maybe some sort of, further insight into some other completely unrelated problem or field. So, and there's actually evidence that this works. I actually do have evidence of this. So, a while back, in the, 70s or whatever, there was a model for quantum chromodynamics that involved strings. So like they wanted to model the interactions with, the quarks and gluons or whatever with these strings. But that was later disproven, there's a current model. I don't know what it is. I think it's called the quark soup. There's all these particles popping in and out of existence. I don't know. Yeah. But anyways, if anyone still believed in this string thing, then they would be promoting pseudoscientific ideas, right? Because we've already falsified that model. But even after this model was...
For clarification, I don't think it would be pseudoscience because it was falsifiable. It's just been shown to be wrong.
Yeah. It would be. I think it still would be pseudoscience because, like, for instance, in the electric universe is based on plasma cosmology, which was actually a real avenue of scientific research back in the day, but it's been disproven. And yet these people are still promoting it as actual science. So, I mean, if you promote a disproven theory as actual science, I don't know, I would consider that pseudoscience. I'm not sure. That's just me. I don't know. But in any case, the discarded idea actually became the seed for a whole new idea. And well, the idea was string theory, right? Maybe if strings don't work in this one instance, maybe they work in this other instance, in this more general sort of case scenario. And so that's actually how string theory first developed, is it was based on a disproven model about quantum chromodynamics. And they realized that the math could be applied to, you know, modeling elementary particles as strings. And then that's how string theory came about. So now, obviously, I don't believe in string theory. I'm not a proponent of it because it kind of falls into that realm I talked about earlier, right? It's actually not technically infinitely falsifiable, but it's really close to it. Because if you look at string theory, at least 10 to the 500 different variations of string theory exist. Like, can you imagine that? There's 10 to the 500. That's like so big, it might as well be infinity, right? For all intents and purposes. And there's no way in string theory for us to determine which one of those is our own universe, and also why our universe would be the only possible, you know, one of those 10 to the 500 universes to exist. So I don't know. I'm not a big fan of string theory for that reason. But I don't know. So anyways, I'm getting off track again. Yeah, I'm so sorry for doing that so much.
It's getting a bit long.
I know. I'm so sorry.
All right.
But anyways, as don't worry, I'm at my conclusion right now, basically. I just wanted to know, like, sort of what I would need to begin something like this. Like, for instance, I would need to learn more about physics in order to do any of this, right? Especially the relation between physics and math statements. Because I would need to, like, have sort of a workflow like this, right? I would need to be able to convert a verbal statement to a math expression, but I would need to have some sort of toolkit, you know, some sort of basic understanding of physics modeling and how to use, you know, how various physical concepts interact with each other, to be able to translate this. And then I'd also need that in order to build up from the bottom up to create this GUT, right? I would need to have, it's sort of like an ingredients list, right? I need the axioms of this pseudoscience. I need all those math expressions I've already derived, each representing a claim. And then I need some sort of toolkit to sort of wrap them all together into a pretty bow, into the grand unified theory. So anyways, that's what I would kind of need. Now, unfortunately, you know, I'm in a biological institution, not a physical physics one. So I don't really have easy access to a physics professor or anything like that. And even if I did tell you earlier that I have the understanding of a 5-year-old, right? When it comes to physics.
Well, you've got, in that aspect, you've got flat earthers beat by 7 years.
Oh, really?
Yeah.
Wait, but that would make them -2 years old.
That's right. Exactly.
Yeah. So I don't know. But I have a weird way of learning things. Like, it often takes, you know, sometimes I pick things up really quickly, but other times, like in physics, like I need something explained to me like in 10 different ways before I finally get it. So I'm not, so even if I found a physics professor, their patience level would be the thing that most likely would, you know, be a problem. I know a lot of physics professors, they don't have a lot of patience. I don't know if that's, you know, I don't know. But, you know, anyways, if you know any resources or if you know of any physicists or people who have at least some knowledge in physics who would be willing to help me create this toolkit, who would probably be invested in this, you know.
Well, I would suggest getting on Discord and going in there and see if anybody there might be interested in this kind of a. It's a long game LARP. So
A long game lark.
LARP, LARP.
Oh.
Live action role play.
Yeah.
So it sounds fun.
Okay, I'm at my I figured I'd bring this up to you because I know you like to bring up different projects and stuff like that to help go against all these pseudoscience stuff. So, you know, this would be a good example of a project, right?
Yep. It sounds fun. I can't do it. I can't be involved. I'm busy.
Well, I know you're busy. You're a busy man. I don't know, but yeah, I don't know if there's anyone in the chat.
There you go. All right, so
I'm sure there's physicists in your chat. So.
Are you on Discord other than on Viki's account?
Yeah, I do have my own account.
Okay.
Yeah, I don't always hijack his.
Message me there, and if anybody wants to participate, you could message me, and I'll connect you all.
Okay.
How about that?
Yeah. So thanks for that. For your help there, and also I'd like to thank you for listening to me. My throat is it's scratchy already because you know I've chatted for so long. Yeah. So thanks for dealing with that.
So people, if the next Action Lab video you notice the guy's voice being a little scratchy, you know why.
Yeah. So in today's video, I'm going to be trying to you know, see if this tube can actually carry water all the way up with a vacuum pump, or I don't know. I'm just making up something.
Oh my gosh, that when you try, it's just it was it. Wow. All right, so if we need voiceover video for fake Action Lab guy, I know where to go.
Mm-hmm. And when you how I'd like at some point to eventually be able to come back to this stream and look at the chat, because you know I wasn't looking at the chat for most of the. Is that possible or not?
It's still up, yeah. I'll leave this up.
Okay.
And so yeah, YouTube will remove the live chat if I like modify the video, like if I blur out some information, or if I chop the beginning or ending, or if maybe sometimes there's some copyrighted material. YouTube has a way to edit that out. Any of those actions will remove the live chat. It's frustrating that they do that, but I don't do that generally. So
okay, I'll be fine then.
Yep.
Yeah, I just want to know what's going on and stuff. So
I think the puns on birds at the beginning were pretty good.
They'll have to look at that again.
So
alrighty. So I don't want to keep you too long. I know. Yeah, you probably have to go somewhere.
Yeah. Well, I have to record a little bit of a video, but maybe tonight for Friday. But hey, thanks for filling in for Viki Chicken. Maybe Viki can apologize for backing out to me. That'd be nice.
I'll make
Viki.
sure he does.
All right. Well, People, thanks a lot. If you are interested in Jonathan's project, let me know. I'll connect you.
Just in helping me learn physics concepts. That's all I need help with. It's just physics concepts.
Yep. And then if anybody is looking for voice talent, specifically Action Lab, we also can connect you there with his hourly rates. So
I will charge a hefty sum.
all right. Well, thanks a lot. We've got a couple things here. Mr. Q Tube, first name Fa, says, so how did anything work before we had computers? Obviously, nothing could have. And then finally, Holy Smalls says, I rescind my skepticism. This guy can't be a flirt.
Oh,
so
thank you.
There you go. You redeemed yourself. So,
yes, at the last minute.
All right. It was a while ago. All right. Well, thanks a lot for coming on, Jonathan. And
I'll send you a Discord message right now
with your real account. Awesome. All right. We'll see you everybody later.
Yeah. Bye.